Alright guys, you should have out a clean piece of notebook paper so that you can take notes over the challenge video problems. Remember, these problems will get you to be able to achieve that level 4, that advanced level on the DCA. Okay, so we'll go through a couple examples and then I'll give you 2 to try on your own so that hopefully you are able to get a level 4. Okay. Alright, so all of these problems are going to be very critical thinking type problems. Okay, they're all going to involve missing exponents to where you have to figure out what they could possibly be. Okay, so in this one, they're saying that 9 to the 4th power is the same thing as 3 to what power? Okay, so in order to figure this one out, you really just need to understand what 9 to the 4th power is telling you. Okay, so 9 to the 4th power is the same thing as 9 times 9 times 9 times 9. Okay? So we need to figure out if it's 9 times 9 times 9 times 9, what would that be in terms of threes? Well, hopefully you can recognize that each 9 is made up of 2 threes. So if I took 3 times 3, I would get 9. If I took 3 times 3, I would get my other 9. If I took 3 times 3, I would get my third 9. And if I take 3 times 3, I would get my fourth 9. So 9 times 9 times 9 times 9, or 9 to the 4th, is the same thing as 3 times 3 times 3 times 3 times 3, 8 different times. So another way of writing 3 times 3 8 times is going to be 3 to the 8th power. So our missing number here is 3 to the 8th. So we're finding equivalents for 9 to the 4th. Guys, you could also go backwards with this. So 9 times 9 would get us to 81. And this other 9 times 9 would get us to 81. So another equivalent to this would be 81 to the 2nd power. So there's lots of equivalents to all of these challenge problems, okay? But we're going to specifically give you the base of 3, and we want to know what is that exponent that it would have to have. All right, let's do another one. All right, if I do 4 to the 12th, what is that in terms of the base of 16 to some exponent? Okay. Now, some of you are going to start recognizing the patterns that go along with these, okay? But I'm going to go ahead and break apart 4 to the 12th. And instead of writing it in terms of 4, I'm going to need to write it in terms of 16. Okay, so I know that in order to have a base of 16, I would need to have 2 of those 4s be multiplied together. So I need to figure out how many 16s make up these 12 4s. So 4 times 4 makes up 16. So 4 to the 12th power is the same thing as 16 to the 6th power. I'm going to have you take this one step further. Could you also then tell me what that would be in terms of 2 to the what power? So instead of breaking apart the 16s or breaking apart the 4s, you're going to have to go the opposite way. So how many 2s would make up all of those 4s? So pause the video and go ahead and do that and see if you can figure it out before I tell you. All right, so those 12 4s broken apart into 2s would be 2 to the 24th power, because each one would give me 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Okay, so we're just trying to find equivalent exponents to go with these problems. All right, now this next one's going to be a little bit tougher, maybe. Okay, so we're going to give you a problem that has lots of missing exponents. But we're going to say that you need to figure out what this math problem would be using only these 4 exponents. So we're giving you the 4 numbers that we want you to use by filling them into these boxes, okay? But you have to get the correct answer. So it's not just a matter of putting them wherever you want. You have to put them into the right spots to get the correct answer. Guys, this is kind of just a matter of guessing and checking, okay? Or you have to know and understand the exponent rules so that you know how they would have come up with those answers. So I'm going to start off just by plugging in those numbers into any spot and seeing if it works. Okay, so I know that the number that I have to have as my exponent is 12. That's the only one I haven't used. Well, I know to simplify this on the top, I would have to take 5 plus 4, which would equal 6 to the 9th over 6 to the negative 3. And then I know using the quotient rule, I would need to take 9 minus a negative 3 to get 6 to the 12th, which is the exponent that I needed. So I ended up being right the first time. Now, so your final answer to me would be 5, 4, negative 3, and 12. Now, guys, there's more than one way of getting a correct answer and making this work. So using those same numbers, I'm going to do it again, okay? So that's one way that worked. Let's see if we can find another way that works. Okay, so let's plug in, let's do 12 on the top, let's do 5 on the top, and let's do negative 3 on the bottom. We'll see if it works. So 12 plus 5 would be 6 to the 17th. Well, I already know, guys, that answer is going to be way too big because the only one I haven't used is 4. So that's not going to work. So let me try again. So the 4 was going to be my answer on that one. So let's do 6, 12, let's do negative 3 because I think I need to get that number smaller on the top. So let's do 5 on the bottom. So I would need to combine 6, 12 plus a negative 3 would get me 6 to the 9th. And then 6 to the 9th minus 5 would get me 6 to the 4th, which was what my final answer would need to be. So 12, negative 3, 5, and the answer being 6 to the 4th would also work. So there's multiple different ways that you can go about simplifying and figuring out how to plug those in. But you have to understand the exponent rules in order to simplify them. All right, so let's do one more like that. Okay, let's do this one, and your numbers that you have to use are 4, 2, negative 3, and 5. Okay, I think that you should pause your video and try and work this one out on your own before I talk you through it and see if you can come up with a couple possibilities, because there, again, is more than one possibility. All right, so I'm going to just throw them down in here. So that means 4 would have to be my answer on the exponent on this. So I'm going to leave 2 to the 5th. 2 plus negative 3 is 2 to the negative 1st. But then when I take 5 minus a negative 1, I'm going to get 2 to the 6th instead of getting 2 to the 4th. So that's not going to work. So let me try another one. Let me try 2 to the 4th over 2 to the negative 3rd, 2 to the 5th. So that means that the 2 is going to be my answer. So let me see what I get. So 2 to the 4th, and then negative 3 plus 5 is 2 to the 2nd. And then I subtract these using the quotient rule. So I get 2 to the 2nd. So that works. So plug in my exponents back into my problem. So that's one of the possible solutions that you could have gotten. Let me go over another one that you could have gotten. Oops, I needed that. All right, so what about if I leave 2 to the 4th and I throw in some different numbers on the bottom? So what about 2 squared and then 2 to the negative 3rd, which means my answer would have to be 5 if I get them correct. So 2 plus a negative 3, to combine those, I got 2 to the negative 1st. So then using the quotient rule, I would take 4 minus a negative 1, and I get 2 to the 5th. So another possibility here is 2 to the 4th over 2 squared times 2 to the negative 3rd is equal to 2 to the 5th. So guys, there's lots of different ways that you can come up with the final answer here. You just kind of have to play around with the numbers a little bit. But you do have to know your exponent rules in order to be able to figure them out. All right, I'm going to give you 2 practice problems, one of each. You have to use 2, 3, 5, and 6. And I want you to try and come up with the 2 different possibilities that those could work out on number 2. As always, if you have questions, please ask.